Right, so again, we're just solving radical equations. Now, in our next set of examples, we have two radicals to deal with. So anytime we have two radicals, we just need to get a radical on each side of our equal sign, and then we just raise it to whatever power we need to get rid of the radicals. Okay? So that means for this one, I'm going to actually add this entire group over to make it positive. So we're going to have the square root of 3x plus 2 equals the square root of 2x plus 7. And then because they're square roots, I'm going to square each side. So that's going to give us 3x plus 2 equals 2x plus 7. And then we have a linear equation, so we can subtract the 2x to each side, and at the same time subtract the 2. So 3x minus 2x will give us x equals, and then 7 minus 2 is 5. And again, we should check to make sure that this is going to work. So I'm going to substitute 5 into both the x's. So 3 times 5 is 15, plus 2 is 7. Okay, so we have the square root, 17, minus, and then again 2 times 5 is 10, plus 7 is 17. The square root of 17 minus 17 is 0. So yes, we do have a correct answer. On the next example, we have it to the 1/2, so again that's radical. So that means that I can just square both of these. And again, that's going to cancel each of them out. So 7x plus 6 equals 9 plus 4x. And then we're just solving for x, so I'm going to subtract 4x. And at the same time, I'm going to subtract the 6. So 7x minus 4x will be 3x equals 9 minus 6 is 3. And then we would divide to get x equals 1. And again, we just need to check to make sure that it's going to work out. So we're going to substitute 1 into both of the x's. So 7 times 1 is 7, plus 6 is 13. So this really means the square root of 13 equals. And then 4 times 1 is 4, plus 9 is 13. Okay, so again, that's going to work out. So I know that x equals 1 is my final answer to that problem. All right, last two examples for the section. So this one we only have one radical, and it's already by itself. So that means that I can start by squaring each side to get rid of it. Okay, so that will leave us with a negative 3x minus 5. This side I have to remember to FOIL since it's a binomial being squared. So we'll have x squared plus 2x plus 1. And it's quadratic, so I need to move everything to the same side. So we're going to add the 3x and the 5. And then we're going to try to factor. So we have 0 equals x squared plus 5x plus 6. So two numbers that multiply to be 6, add to be 5 will be positive 3 and positive 2. So my two possible answers right now would be negative 3 and negative 2. And then we need to check to make sure that both of those numbers work. And we're going to substitute negative 3 into both of the x's. So negative 3 times negative 3 will give us a positive 9. 9 minus 5 is 4. So we have the square root of 4 equals. And then negative 3 plus 1. So that would just be a 2 equals negative 2, which is not a true statement. So that means that negative 3 is extraneous. And then I just need to check the other problem. Okay, so negative 2 times negative 3 is going to be 6, and 6 minus 5 is 1. So we have the square root of 1 equals, and then negative 2 plus 1. So I have 1 equals negative 1, which also is not true. So that means that we have two extraneous solutions. So my overall answer then is no solution for this problem. And our last example, so we have two radicals. So we need one on each side of our equation. So I'm going to add the square root of x over to the other side. So we would have the square root of 5x plus 4 equals 4 plus the square root of x. And then we need to square each side. And again, when we are squaring this side, this is really a binomial. So on this one, the radicals cancel nicely, so 5x plus 4. But on this side, to square it, I need to FOIL. So we have 4 plus the square root of x times itself. So 5x plus 4 equals 4 times 4 is 16. And then we'll have 4 square root of x plus another 4 square root of x. So that is 8 square root of x. And then the square root of x plus, or times the square root of x will give us the square root of x squared, which we would then just simplify to be x. So notice on this problem how we still have a radical. So if that's the case, then we need to isolate that term again. So we're going to subtract the 16 and the x. So this will be 4x, and then 4 minus 16 will be 12, equals 8 square root of x. And we could divide by 8, but that's just going to give us a fraction to work with. So instead, to get rid of this radical, I'm just going to square each side. Okay. So again, here we have to FOIL. So we're taking 4x minus 12 times itself. And then 8 squared is going to give us 64, and then the square root of x squared is x. So 4x times 4x will be 16x squared. And then 4x times 12 is going to be 48x, and it's going to be a negative. And then we'll have another negative 48x. So if we just add those right away, that will be a 96x. And then negative 12 times negative 12, oops, sorry, this should be a negative 96x. And then that'll be a positive 144 equals 64x. So now I need to subtract that 64. So negative 96 minus 64 is going to be a negative 160. So again, we need to figure out how we're going to factor. Now looking at this, we should be able to simplify. So all of those numbers are divisible by 4. So I'm going to divide everything by 4 before we continue. So we'll have 4x squared minus 40x, and then 144 divided by 4 is going to be 36. So it looks like we'll be able to divide by 4 again. So if we divide everything by 4, again, this will give us x squared minus 10x plus 9 equals 0. So that one should be nice and easy to factor. So two numbers that multiply to be 9, add to be negative 10, will be x minus 9, and then x minus 1. So again, our two possible answers for this problem, so I'm going to write it at the top here. So x equals positive 9 and positive 1. And we have to check to make sure that they both work, and we're going to substitute it into both of the x's from the original problem. So let's start with 9. So 5 times 9 is going to be 45, and then plus 4 will be 49, so square root of 49 minus the square root of 9, and that has to equal 4. So we are going to have 7 minus 3 equals 4, which is a true statement. And we have to do the same thing with the 1. 5 times 1 is 5, plus 4 is 9. So we'll have the square root of 9 minus the square root of 1 equals 4. So the square root of 9 is 3 minus 1, which does not equal 4, so that is an extraneous solution. So the only answer to this problem will be x equals 9.